continuing with these connected particles, we have 2 kilogram, 4 kilogram, 1 kilogram, and we've got coefficient of friction is 1/2, and we're given this diagram here. I've got my 1, my 2, my 4. So we've friction going along here. So let's do 3 diagrams here. So here's my 1. So we can say the system's going to move this way. This one is going to go up. We'll call the tension in the string T1 and T2. T1, T2. So going down, we have mg, so just 1g. So my equation here is T1 minus g is equal to ma. So just 1a. Now I'll do my 4 next. It's the other one hanging over. 4 is going down this way. This is the second string, so T2, and we have 4g. So 4g minus T2 is equal to 4a. And then we have our 2 kilogram block. So we have mg, 2g. We have my reaction. We have mu or, and we have T2. We also have T1. So straight away I can say or is equal to 2g. So mu or is equal to 1/2 2g times 1/2. Well, that's just going to be 2g divided by 2, which is g. So for my equation, it's going in this direction. So I'm starting with T2, and I'm taking away T1 that's going back and mu or that's going back, and that has to be equal to ma, which we didn't write in, to 2, so that's equal to 2a. So if we bring the other equations underneath, so if I write this underneath and line up my terms, I have T1, I have minus g equals a, and do the same with this one here. I have minus T2 plus 4g is equal to 4a. So I have 2g is equal to 7a. So a is 2g over 7, and g over 7 is 1.4. So the acceleration here is 2.8 meters per second squared. So that's the acceleration. We're asked for the tension in each string. I'll just do it here. T1 is equal to, from this equation, T1 is equal to a plus g, which is 9.8 for g, plus my acceleration of 2.8. 12.6 newtons for T1. T2, do it here. T2 is equal to, well, I can take T2 from the middle equation there. If I bring it to the right, T2 positive, so 4g minus 4a. So T2 is equal to 4 times 9.8, which is 39.2, minus 4 by 2.8, which is 12 minus 0.8, which is 11.2, and 39.2 minus 11.2 is 28 newtons for T2. Okay, a little bit messy. Let's try and make it a little bit neater for question 7. The diagram shows a horizontal table again, and we have this 4 kilogram mass on the table. We have a 10 and a 1, so we can see my movement is going to be in this direction. And I have strings, so I have T1 and T2. We're told it's smooth initially, but we will have roughness as well. So the second equation, we're going to have this mu r going back this way. So 2 different accelerations. So let's draw our 3 diagrams. So the 1 kilo. mg, 1g, T1 going this way. My acceleration is going up. So I'm going to have T1 minus G is equal to MA, or just 1A. If I do the 10 kilo next, 10G going down, this time T2 going up, my acceleration in this direction, so I have 10G minus T2 is equal to MA 10A. And then for my 4 kilo, initially no coefficient of friction, mg, so 4g, my reaction. I have T2 going this way, and I have T1 going this way. So this is the first time. We'll put in my mu r in a different color in a second. So it's going in this direction here. So we can say that T2 minus T1 is equal to MA. This is the 4 kilo, so 4A. So if I combine all three equations, I get my T's to cancel. So I've got T1 minus G is equal to A. T1 minus G is equal to A. I have 10G minus T2 minus T2 plus 10G is equal to 10A. So combining all these three, I'm going to get 9G is equal to 15A. Forget about the 4, it's all three of them. So G is equal to, sorry, no, A, not G, we know what G is. A is equal to 15, A is equal to 9G over 15, which is equal to 3G over 5. MS to the minus 2. 9.8 divided by 5. 1.96 times 3. 5.88 MS to the minus 2. Now, second part, if the table is rough, what will the acceleration be? So that was my diagram here. I'm going to put it in green. I'm going to have mu r. Well, first of all, we're going to do r is equal to 4g. Mu r is equal to 4g divided by 2 is 2g. So my equation for this one becomes T2 minus T1 minus 2g is equal to 4a. So how's that changed everything up here? You can see, well, I'll line the other equations up anyway. T1 minus g is equal to a, and minus T2 plus 10g. You probably wouldn't have to go through all of this, but you know, better to just do it. Take your time while doing these. There's no rush here. So you can see we're going to get 10 minus 3, so we're going to get 7g is equal to 15a. The 15a stayed the same. All that happened was we were taking away another 2g, which was this mu r. So you can see here, you can kind of see the relationship about what's happening to go from here to here. So a is equal to 7g over 15. That doesn't work out too nicely. It's a repeating decimal, 4.573 repeating meters per second squared. Okay, number 8. Two particles of mass 5 and 4 are connected by a light, inextensible string passing over a smooth, light, fixed pulley. So just a quick sketch. So it's looking something like this. And we have a 5 and a 4. The particles are released from rest and calculate in terms of g, acceleration, tension. Okay, let's have a look here. What's going on with this 5? 5, we have mg, 5g. We have tension in the string, and for the 4, we have 4g. And we have tension in the string. So we need to decide which way is it going. And obviously, the 5 is going to go down. So 5 down means 4 up. So 5g minus t is equal to ma, And in this one, we're going to get t minus 4g. It's equal to ma. So I have minus 4g plus t is equal to 4a. So I'm going to get g is equal to 9a. So a is equal to g over 9. Tension, well, tension is equal to 4a plus 4g from here. So my tension is 4 times g over 9. Hard to distinguish the g's from the 9 sometimes with mine. Plus 4g. So I have 4 full g's and I have 4/9 of a g. So I have 36 over 9 is 4. So I have 40 over 9. 4 and 36. So I have t is equal to 40g over 9. So second part here, or kind of no numbered part, if after 2 seconds, so when t is 2, the larger mass is caught, so its velocity is going to be what we need starting from rest after 2 seconds, and we have acceleration g over 9. So we want velocity v is equal to u plus at. So v is equal to, it starts from rest, plus g over 9 times 2. So the velocity of this particle just before it stops is 2g over 9. So that is now the initial speed of my other particle, the 4 kilogram one, or the lighter one. So I have velocity of 2g over 9. So with the second one now, moving across to the lighter one, its velocity, it's going to stop. It starts at the speed the other one finishes at. They were both going the same speed. We're looking for the distance traveled. And the only thing we need then is acceleration. And you guys know that the acceleration of a particle freely falling is g, but before it starts falling, which is what we're looking at here, it's being slowed down. So the acceleration is minus g. So we can use v squared is equal to u squared plus 2as to say that this particle is going to stop if it's going at 2g over 9 and its acceleration is minus g. How far will it go? So we're going to get 2gs is equal to 4g squared over 81. So s is equal to 4g squared over 81 divided by 2g. So I'm going to put just the 2g on the bottom here. And you can see the 2g will divide into the 4g squared. So s is equal to 4g squared divided by 2g is 2g over 81. And we were dealing in meters per second here.